In 2015, Ford unveiled an engine that the automotive world treated as a revelation. It sat inside the Shelby GT350, and it was called the Voodoo. An all-aluminum, 32-valve, double overhead cam V8 with a flat plane crankshaft, the same exotic layout used by Ferrari, that could scream past 8,000 revolutions per minute. Magazines called it one of the most advanced production V8s America had ever built. And in a sense, they were right, but they were also, without knowing it, about 75 years too late. Because Ford had already built an all-aluminum, 32-valve, double overhead cam, flat plane crank V8, it built it in 1940. It made over 500 horsepower, and then the company, and the world, forgot it so completely that when the same architecture returned 3/4 of a century later, almost no one remembered it had been done before. This is the story of the Ford GAA, the most advanced engine of its era, hiding in plain sight inside a tank. To understand how an engine this sophisticated appeared in 1940, you have to start with a war that had not yet reached America, and an aircraft engine that was never wanted. In the late 1930s, with conflict spreading across Europe, the United States military knew it would soon need engines. Powerful, modern, high-output engines in enormous numbers. Ford, with its unmatched mass production capability, was an obvious company to ask. And Ford's engineers set out to design something genuinely advanced, a large V12 aircraft engine built with the most modern thinking available. The design they produced was striking. It used an all-aluminum block to save weight. It used double overhead camshafts and 4 valves for every cylinder, a layout that, even decades later, would still be considered the mark of a serious, high-performance engine. It superficially resembled the legendary Rolls-Royce Merlin that powered the Spitfire, but it was not a copy. Where the Merlin used a single overhead cam and older valve technology, Ford's design used twin cams and modern bucket followers, and crucially, it was engineered from the very start for high-volume production. Ford was not interested in building a handful of exquisite engines. Ford only knew how to build things by the tens of thousands. It is worth dwelling on just how forward-looking these choices were. An all-aluminum engine block, in an era when most engines were heavy cast iron, was exotic and difficult to manufacture. Twin overhead camshafts and 32 valves represented the kind of valve train that, even in the 1980s and 1990s, would be advertised as the height of performance technology. Ford's engineers, working with the slide rules and drafting tables of the late 1930s, had reached for the most advanced configuration the science of the engine then allowed. They were not building to a budget. They were building to win a contract by being the best. There was just one problem. The Army Air Corps did not want it. The American military had little appetite for large, liquid-cooled inline aircraft engines of this type, preferring air-cooled radials for most of its aircraft, and the V12 project was rejected. Ford had poured its engineering talent into one of the most advanced power units in the country, and it had nowhere to go. The engine was, for a moment, an orphan, brilliant, finished in concept, and completely unwanted. And then the need changed, and it changed everything. As America moved toward war, a different and desperate requirement emerged: tanks. The United States needed to build medium tanks in vast numbers, and those tanks needed engines, reliable, powerful, torque-rich engines that could move 30 tons of steel across a battlefield. And here, the orphaned aircraft engine found its purpose. Ford took its rejected V12, and, in a remarkable piece of engineering pragmatism, simply cut 4 cylinders off it. By removing 1 bank's worth of cylinders and reconfiguring the design into a 60-degree V8, Ford turned a dead aircraft engine into a living tank engine. Think about the sheer practicality of that decision. Rather than start over, Ford looked at its rejected masterpiece and saw a tank engine waiting inside it. By cutting the V12 down to a V8, Ford could carry all of that hard-won sophistication straight into a completely different machine. The reject was not scrapped, it was reborn. The result was given the designation GAA, and by any measure, it was a monster. It displaced 1,100 cubic inches, 18 liters, making it one of the largest gasoline V8s ever put into production. It produced around 500 horsepower at 2,600 revolutions per minute and over 1,000 pound-feet of torque. It weighed nearly 1,500 pounds. The all-aluminum construction, the double overhead cams, the 32 valves, and the flat plane crankshaft. The GAA became one of the primary engines of the M4 Sherman, the tank that did more than almost any other to carry American and Allied forces across Europe. Its sophistication completely invisible to the soldiers whose lives depended on it. A tank crew did not see a 32-valve, flat plane crank engine. They saw a roar, a vibration, and the forward motion that kept them alive. Production ran from 1940 all the way to 1950. Over 28,000 of these engines were built, powering Shermans and other vehicles through the war and beyond. By the standards of obscure experimental engines, the GAA was not obscure at all. It was made in vast numbers. It simply happened to spend its entire career hidden where no car enthusiast would ever look, inside a machine built for war, not for the road. And that is the heart of why it was forgotten. When the war ended, the world had no further use for an 18-liter tank engine. The military began moving toward diesel power for its armor, prizing fuel efficiency and simpler logistics over the GAA's gasoline performance. And so, the most architecturally advanced V8 America had built was quietly retired. Not because it had failed, but because the very specific, enormous job it had been created for simply ended. They never appeared in a car. They were never marketed to the public, never put under the hood of something a person could buy and drive. The engine was a triumph of design that the ordinary world was never invited to see. It existed, it worked superbly, and it remained almost entirely unknown outside the military. And when the surviving engines were pulled from decommissioned tanks, they became the property of a small circle of military vehicle restorers and collectors, keepers of a secret most of the car world never knew existed. To them, the GAA was a known wonder. To everyone else, it might as well never have been built. Knowledge that is not shared does not spread, and the GAA's brilliance stayed locked inside that small, devoted community. The mainstream American automobile industry, through the 1950s and 60s and beyond, went a completely different way, but a world away from the GAA's exotic twin-cam, multi-valve, aluminum sophistication. The advanced architecture Ford had mastered in 1940 was not built upon, it was abandoned. And this is what makes the GAA such a strange and quietly profound object. We have a comfortable story we like to tell ourselves about technology, that it advances steadily, that each generation stands on the shoulders of the last, that knowledge, once gained, is never truly lost. The GAA is a counterexample, sitting right in the middle of that story. Here was a piece of engineering knowledge, how to build a large, all-aluminum, double overhead cam, flat plane crank V8 that was fully mastered in 1940 and then effectively set down and walked away from. It took the mainstream automobile roughly 3/4 of a century to walk back to the same place. When Ford engineers built the Voodoo engine for the 2015 Shelby GT350, and the world praised its flat plane crank and its all-aluminum 32-valve twin-cam sophistication as the cutting edge, they were, in the deepest sense, returning to a layout their own company had built before most of them were born. The Voodoo is a genuinely brilliant engine, smaller, lighter, far higher revving, and refined in ways the GAA never was. But it is not the first of its kind that Ford made. And there is no villain in this story. That is what makes it haunting rather than infuriating. No executive maliciously buried the GAA's genius. It was simply born for a job, did that job magnificently, and then outlived the need that created it. Its sophistication was real, but it was aimed at a war, not at a future. And when the war was over, the sophistication had nowhere to live. The most advanced engine architecture in America went dormant, not destroyed, just quietly, completely forgotten by everyone except the few who kept the old tanks running. Perhaps that is the most human part of the whole story. The GAA was not lost because anyone failed to see its worth. It was lost because the world moved on, and the thing it had built for one extraordinary moment no longer fit the moment that followed. Brilliance, it turns out, is not always enough to keep an idea alive. An idea also needs a place to belong, and for 75 years, this one simply did not have one. The GAA was not ahead of its time because it was built for the future. It was ahead of its time by accident, born from a canceled aircraft engine, pressed into a tank, and carrying race-grade architecture into a war it was never designed to advertise. And when the war ended, the most advanced engine layout in the world was simply set down and forgotten, waiting 3/4 of a century for the industry to reinvent what Ford had already built. We like to believe progress is a straight line, and that genius, once achieved, is always carried forward. The forgotten engine inside the Sherman tank is the quiet proof that sometimes the most advanced idea in the world can be built, used, and lost, and that the future is sometimes just the past that nobody remembered. Before you go, at Timeless Treasures, we dig up the engineering history that was buried before the world ever saw it. Subscribe, and let's keep bringing it back into the light.